I'm going to do a correlation question, chapter 15 right now, question 12. In the chapter preview, we discussed a study by Judge and Cable 2010 demonstrating a negative relationship between weight and income for a group of women professionals. The following are data similar to those obtained in the study. To simplify the weight variable, the women are classified into 5 categories that measure actual weight relative to height, from 1, thinnest, to 5, heaviest. Income figures are annual income in thousands, rounded to the nearest thousand. Part A, we're going to calculate the Pearson correlation. Then we're going to decide if this correlation is statistically significant with a two-tailed test and alpha of 0.05. And I need to open this up to see the full set of data. And one thing that I want to do before we jump into that is to chart this out as a scatter plot. And so I have the data written down, and what we're going to do is we're going to do a scatter plot first because we want to check that this is a linear relationship. That is an assumption that is part of the Pearson correlation, which is the most common correlation that we run. And if it's not linear, we shouldn't run the Pearson correlation. We should go and find a different correlation, different type of correlation to run. So what we're going to do is first we're going to do a scatter plot. We're going to have on the x-axis down here, the y-axis is up here. On the x-axis, we have women's weight, and that scale goes up to 5. So we have 1, 2, 3, 4, 5. And on the y-axis, we need to go up to 115. So let's go up by tens. So we'll go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, and then split those in half. So we've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, and I don't label each tick mark because it gets too cluttered for me. I suppose I can be consistent. I can take that one off, but the unlabeled tick marks are the odd numbered ones. So we've got 1, 115, about there. Over a little bit. 1, 78. 4, 16. 3, no, I'm messing that up already. It's 4, 53. That 16 was a bit low. 3, 63. 5, 37. 2, 84. 5, 41. 3, 51. 1, 94. And 5, 44. And so you can see here, it's not overly problematic to have it like exact. We can see a downward slope, right? So we're expecting, when we calculate, we're expecting a negative correlation. So we're expecting a negative correlation because this line is sloping downwards. So that's what a negative correlation is. A negative correlation is one increases, the other decreases. So as the weight variable is increasing, the income variable is decreasing. And they cluster pretty tightly around that line. They're not all right on the line, so it's not a perfect correlation, but we are expecting quite a strong correlation. The number, ignoring the sign, so ignoring plus or minus, the number is likely to be pretty big. Close to -1 is likely what we're going to see. So now what we can do is we can calculate the Pearson correlation.